Welcome to this video on multi-step word problem strategy. Multi-step word problem strategy is really not that much different than regular word problem strategy. We just need to be focused on looking for more than one operation to apply and do it in the right sequence. But in review, let's talk about the 5-step process for approaching word problems. Read carefully. With more difficult problems, read even more carefully and make sure you're focused on what you're being asked to find. We don't want to answer the wrong question. Find the important information and also the unimportant information. Knowing what you're being asked to find can help you identify the things that you need to figure that out and the things that you don't need. Choose the right operations. Emphasis on the S here, that we're looking for multiple operations that we're going to apply, and we're going to have to think about the sequence that we're going to do them. Are we going to add first and then divide? Are we going to subtract first and then multiply? What is the sequence of operations that we want to do? Once you've decided on that, you go ahead and you do them. And then finally, check to make sure that that answer sounds reasonable. That may be even more important for multi-step because you might come up with some very ridiculous answers if you do the operations in the wrong sequence. So checking that answer can help you avoid making that mistake. Go back and check your work if it doesn't sound reasonable. Example problem 1. This is kind of a classic, simple multi-step word problem. You have $700 in a bank account. The balance in the account is reduced by paying a $125 medical bill, and then you deposit a check for $60 from a friend. How much is in the account after these transactions? How much is in the account after these transactions? We had $700 in the bank account at the beginning of this problem. Then we paid a $125 bill and we deposited a check. That's really all we need here. There isn't any unneeded information really. So we can think of this as 2 steps. Step number 1 might be to pay the medical bill. So we start out with our balance and we subtract 125. And we get $575 that's left in that account. Step 2, let's put the deposit in. So we take our $575 that we have at that point, and a deposit is an addition to our balance. Paying a bill is a subtraction. So we add the $60 and we get $635. Now, when you looked at this problem, if you immediately thought, hey, I know how to do that, 700 minus 125 plus 60 equals 635, you are absolutely correct. We didn't quite break it up into these discrete steps, but you still performed 2 steps here. You subtracted 125 and then you added 60. But that is perfectly fine. That's good logic. You have the gift budget of $140 and want to buy one $60 gift and 4 other gifts of equal value. How much will you be able to spend on the 4 other gifts? How much will you be able to spend on 4 other gifts, and they are going to have equal value? So that sounds like division, but we need to know how much money we have left before we can do that division. So let's find out how much money we have left. That's going to be step number 1. So we started with 140. We are going to subtract what we spend on the first gift, $60. So we have $80 left to spend on those other 4 gifts. Step number 1. Step number 2, Let's do the division to find out how much each one of those equal gifts will be. So we have our dollars left, and we are going to divide that by the number of gifts. We have $80 left. We divide by 4 gifts, and each of those gifts will be $20. Welcome to this video on how to work between fractions, decimals, and percents. Fractions, decimals, and percents are all related, meaning if we know one of them, we can find the other two. And that's what we're going to work on in this video. Here's an example. We have a fraction of 1/10. That's related to the decimal of 0.1, which is related to the percent, 10%. All of these have the same value. So that's why if we know one, we can find the form that represents the other two. So let's get to work on that. How do we convert between these? We're going to focus on 4 conversions from fraction to decimal. Then we're going to go from decimal back to fraction. We're going to go from decimal to percent, and from percent back to decimal. This will give us everything that we need. Now, if we have to go from a fraction to a percent, we're just going to have to do 2 steps. We'll go from fraction to decimal, and then from decimal to percent. And our example problems that we have today will do exactly that. So you will get to see that. Here's the first conversion we want to do, which is from a fraction to a decimal. We want to convert 3/8 to a decimal. How do we want to do that? Fortunately, this is pretty easy. You just divide. You divide the numerator by the denominator, and that is going to give you the decimal equivalent. So 3 divided by 8 equals 0.375, which equals our answer of 0.375. It's that easy. Just divide to turn a fraction into a decimal. Going back the other way is definitely the most difficult of these 4. So let's go through that. We want to convert the decimal 0.125 into a fraction. We are going to place these numbers 125, actually 125, over one of these numbers in order to create a fraction. And the number that we choose is going to be based on the number of values we have. 1 decimal, 1 value to the right of the decimal place, we would choose the number 10. 2 decimals, the number 100, and 3 decimals, the number 1000. And we have 3 here, so that's what we will use in this example. And then finally, we want to reduce that fraction to the lowest terms. So we start out with 0.125. We set that up as a fraction, 125 over 1000. Those have the same value. You can prove that to yourself by doing the division here. Set that fraction into your calculator or do 125 divided by 1000, and you will get that decimal. Then we reduce that fraction, and that fraction reduces all the way down to 1/8. Now, once again, a reminder that we used the number 1000 for our denominator because there were 3 values in our decimal that we were converting. 3 values to the right of the decimal point. Okay, let's convert a decimal to a percent. We are converting the decimal 0.125 to a percent. This is pretty straightforward. There's 2 methods that people will use: multiply the decimal by 100, or move the decimal point 2 places to the right. These will accomplish the same thing. And then add the percent symbol. So we take 0.125, we multiply by 100. I encourage you to follow along with these calculations so you get the same result. And we get the number 12.5, but we want to make sure that we add that percent symbol so that we are describing 12.5 as a percent. Okay, on to the last one. We are now going from a percent to a decimal, and you might be guessing we just have to do the opposite. And that's exactly right. The opposite of multiplying by 100 is dividing by 100. And that's what we can do to convert this to a decimal. Or we can move the decimal 2 places to the left. And then we drop the percent symbol because decimals do not have a percent symbol. So we take 32.5 divided by 100. That equals 0.325. That's our decimal. In this video, we're going to focus on converting between units of measure in order to solve math problems. So first of all, what are units of measure? Units are used to describe the amount of distance, capacity, weight, time, etc. And here are some examples. So for distance, depending on the amount that we're measuring, we might use a variety of different units like millimeters, inches, feet, meters, yards, miles for really long distances. Similar for capacity, teaspoon, cup, liter, quart, gallon, cubic foot. For weight, we have a number of different measurements like grams, ounces, pounds, kilograms, and tons, all used to measure the same kind of thing, but for different amounts. And similar for time, we have seconds, minutes, hours, days, months, and years. So using a unit conversion reference can help you convert between units for a similar kind of measurement. It's important to note that the unit with the smaller number in front of it is the larger unit. Let me make an example from this unit conversion reference. This is just an example reference. There's all kinds of these available depending on what you're converting between. But let's just take a look at one that's pretty familiar. We all know that a foot is larger than an inch. Notice that it's 1 foot equals 12 inches. So the unit with the smaller number in front of it, in this case, 1 is in front of feet, is the larger unit. Inches has the bigger number, that's the smaller unit. The same thing applies to pounds. 1 pound equals 16 ounces. Ounces are smaller than pounds. So you'll understand why I'm focusing on this when we get to the rules of unit conversion. And that starts right here. Do we multiply or divide? When you're doing a unit conversion, you're either going to multiply by a number or you're going to divide by a number. But you need to decide which, and it's really important. In this case, I have this example where we have 1 yard, and 1 yard contains 3 feet. It's very clear that feet is the smaller unit, yard is the bigger unit. How do we make use of that information? If we're converting to a smaller unit, in this case, from yards to feet, we're going to multiply. We are going to have more feet than we had yards. For example, how many feet are in 15 yards? Look up the conversion factor. 1 yard equals 3 feet. This tells us that yards are the bigger unit. Feet are the smaller unit. We're converting to the smaller unit, so we should multiply. Multiply by 3, 15 times 3, there will be 45 feet in 15 yards. Let's look at a different example. 1 gallon, 4 quarts. Quarts are the smaller unit. There are 4 of them in 1 gallon. That's what these lines are meant to indicate. Gallon is the bigger unit. Quart is the smaller unit. When we're converting from quarts to gallons, we're going to a bigger unit. We need to divide. There will be smaller. There will be fewer of that bigger unit. So we get a smaller number by dividing. For example, how many gallons are there in 15 quarts? Look up the conversion factor. 1 gallon equals 4 quarts. We're converting to a bigger unit, so we should divide. Divide by 4. 15 divided by 4 equals 3.75 gallons. In this video, we're going to talk about finding solutions to problems that involve sequences or patterns in objects or numbers. So the key to solving these problems is to identify the pattern in a sequence of numbers or the count of a number of objects. An example question might be something like this. What is the next number in the following sequence? We're given 4 numbers, and maybe we're trying to find the 5th number, or we're trying to find the 10th number in this sequence. We're not going to solve that particular problem, but next we're going to talk about some strategies that you can use to identify the pattern. These are the steps. First, try to figure out if one number is being added or subtracted to get to the next number. So how could we do that? Here's an example. And the classic method is to subtract. Start by subtracting the first number from the second number. For example, here we have 3 and 6. So let's subtract 3 from 6. That gives us the number 3. Then we do the same thing with the next pair of numbers. 9 minus 6. That's also 3. We do it one more time. 12 minus 9. That's also 3. So what that tells us is that the pattern, or the rule that's being followed here, is to add 3 to get to the next number. So the very next number would be 15 plus 3, or 18. And we could keep going as far as we needed to go. So that's the most basic kind of pattern, where one number is being added or subtracted to get to the next number. Another way to develop a sequence is to multiply or divide. So what we're looking for here is a number that's being multiplied to get to, or divided to get to the next number. The way we can check this out is to divide. 9 divided by 3 is 3. 27, the third number divided by the second number, divided by 9, is also 3. It's just a coincidence that both of these use the number 3. There's nothing magical about the number 3 here. Oops, not divided by 3, divided by 27. So 81 divided by 27, you guessed it, that's also 3. So the rule being used here is that we multiply by 3 to get to the next number. So 81 multiplied by 3, the next number, I hope you're doing this along with me, would be 243. In this video, I'm going to talk about exponents and roots. These are basically shortcut notations that tell us to perform certain math operations. So this is an example of an exponent situation. We have what we might refer to as 7 to the third power, or 7 to the exponent of 3. We refer to the 7 as the base. This is the number that's going to be multiplied by itself a certain number of times. The exponent is what tells us how many times we're going to multiply it. So in this case, we're going to multiply 7 times itself a total of 3 times. We would say this as 7 to the third, or 7 to the third power, or 7 to the exponent of 3. 7 to the third is probably the most common. And that's the math that we would do if we were going to kind of do this by hand. We're going to talk about doing it a little bit quicker in the calculator, but 7 times 7 times 7 is what's being communicated up here. In this example, we have 5 to the second power. That means 5 times 5, and 5 times 5 is 25. So the reason that I'm showing this example is that 2 is the most common exponent. So we have kind of a special way to describe that. We call something with an exponent of 2 squared. So we would refer to this math up here on the left-hand side where we started as 5 squared. Now, let's talk about roots a little bit. Here we have what we would describe as the square root of 16. That means what number multiplied by itself will make the number. Which number multiplied by itself will make 16? So you can see we're describing this then as the square root of 4 times 4, because 4 times 4 is 16. So the answer to this is 4. It's kind of undoing a square. It's the opposite of squaring. Since 4 times 4 is equal to 16, the square root of 16 is 4. That gets a little bit confusing, but for the most part, we're going to rely on the calculator to do our squares and square roots. So this is the button that you're going to use, and you're going to use it for both squares and square roots. There we go. So I'm going to do what I just described, 5, and then I click. This looks a little bit different, but it's really the same as your calculator. I click on the x squared button and then enter. And I get, you can see that it shows me 5 to the second power, or 5 squared is 25. Now, if we want to undo that and take a square root, we have to do it a little bit differently. We're going to click the second key, then the x squared button. But because we click the second key, it gives us the square root function, and we can clearly see that. And then we type our number in at the end, and it goes underneath that square root symbol. Then we click enter, and you can see that we get back to 5. So that's how we can kind of go back and forth. Let me do that square root thing one more time. Second square root. Let's do the square root of 49. And we click enter, and we get our answer, which is 7. In this video, I'm going to talk about scientific notation. Scientific notation is just a more convenient way of communicating really small or really large numbers. Here's an example. 1.432 times 10 to the third. So what are the characteristics that we're looking for in scientific notation? The first is that we only have one number or one digit to the left of the decimal point. In this example, we have a 1. It needs to be something between 1 and 9, but not 0. So that is a key characteristic. Next, we're looking for a multiplication symbol. And finally, we have a 10 times 10 to some exponent. And that exponent is either going to be positive or negative. If the exponent's positive, it means we're talking about a large number. If it's negative, we're talking about a small number. Let's talk about the rules for converting big or small numbers to scientific notation. So the first thing we want to focus on is getting that exponent. What is the value of that exponent? And what we're going to do is count the number of decimal places to get the decimal to the right of the first number that's not a 0. We'll go through an example in a moment. For big numbers, I'm talking about big numbers, numbers that are 10 or larger, the exponent will be positive. And for small numbers, numbers that are less than 1, the exponent will be negative. So here's an example of a large number. Now let me show you this process of counting. First of all, when there is no decimal place shown, we can assume that it's right there after all of the numbers. And now we're just going to count the number of decimal places to get our decimal right here, so that we will have a 1 to the left of it. 1, 2, 3, 4, 5, 6. We have to move the decimal point 6 places. We know that our answer in scientific notation is going to contain a 10 to the 6th. Is that 6 a negative or a positive is another question. Because we are dealing with a big number, it's going to be positive. So we can kind of leave that alone. And then we simply write what's left of our number. We're going to ignore all of these zeros to the right-hand side, And we're just going to write 1.5 times 10 to the 6th because we moved the decimal point right there. 1.5. Again, we can ignore all of those zeros. They don't really help us out. Okay, let's take a look at a small number. So in this case, we need to move our decimal point right there between the 6 and the 4. And notice we're going the other way. That's because it's a small number. 1, 2, 3 decimal places. So our answer is going to have 10 to the 3rd, but because it's a small number, it's 10 to the -3rd. And then let's fill in what our number is. We have a 6 to the left of the decimal. Remember, we will always have one digit there. And then 0.4. All right, sometimes you'll have to convert from scientific notation to what we call standard form. Standard form just means kind of a regular number. The exponent tells you how many places to move the decimal. Positive exponent means move right. Moving right will give us a big number. A negative exponent means move left. Moving the decimal point to the left will get us a small number. This is the hardest part of the scientific notation, is keeping the direction straight, whether the exponent should be negative or positive. With a little bit of practice, this will come pretty easily. In this case, we see that we have 4.43 times 10 to the 4th. The fact that this is a positive 4 should tell us big number. We're going to end up with a big number. That means we should move to the right. So we could rewrite this. And we're going to move to the right 4 places. We're going to start here. We're going to go 1, 2, 3, 4. Now notice we moved way out here and we've kind of jumped over numbers that don't exist. What we should do is put zeros in those places. So that's the number that we're talking about. We should also put a comma in it. There should be a comma after the 3 digits. So that would be 44,300. 3.21 times 10 to the -2. Right away, we should take note of this and say, oh, -2, this is a small number. I better end up with a small number. So let's rewrite what we have here. Actually, I'm going to do it with the number that's already there. We're going to start here, and we're going to move our decimal 1, 2 places to the left. This is going to be our new decimal place, and we should add a 0 here because we're missing a digit. So now we could rewrite that. We should always put a 0 before the decimal point too when we're writing in standard form. 0.0321.